this video, I'm going to give you a brief overview of how the MoraMapGen system works, then give you a quick start rundown, followed by a complete setup walkthrough. Then we'll cover prop placement in detail, reflection probe placement, NavMeshSurface baking, and finally go through every setting in the inspector reference section. MoraMapGen is a procedural level generation tool that creates unlimited layouts of rooms and corridors, great for dungeon crawlers and roguelikes where maps need to be generated on the fly and be endlessly unique with each playthrough. Layouts are assembled from a sprite sheet of predefined tile options, which you can edit. It uses a wave function collapse algorithm as well as post-processing so you can customize the look of your layouts. For demonstration purposes, here you can see what's happening step by step. It establishes the bounds based on your size settings. Then it does a pure wave function collapse to fill the level. Then it removes the corridors so it can process the rooms. Based on your preferences, it can split any large rooms and then remove any small rooms. Then, using your corridor design settings, it will connect the rooms with corridors and even fill some of the extra space. When done, your module prefabs are used to skin the level. Props can then be procedurally placed as well. You can generate in editor to bake to prefabs, or you can generate at runtime. In either case, you can use a specific seed to maintain a specific layout, or randomize it so that every playthrough is unique. To get started using MoraMapGen, you can of course explore the various demo scenes provided, but to start using it in your scene, create a new empty game object and make sure it's centered. Add the MoraMapGen component. The next thing we need is to specify what map generation settings to use. You can either select an existing settings asset from the demos, or you can create a new one. To create a new settings asset, either click the New button in the inspector, or right-click in your Assets folder and select Create MoraMapGen MapGen Settings Asset, and then assign it in the inspector. If you chose to create a new settings asset, you'll need to also assign an area options asset. An area options asset defines what rooms and corridors should be used in the layout. For now, let's use one of the existing ones from the demo scenes. To learn how to create your own area definitions, as well as the prefabs to skin them, watch the complete setup section of this video. Now that we have an area options asset assigned, we can click Generate Map. You can also make any changes to the settings that you'd like and regenerate to see how it affects the layouts. I cover all of these settings in detail in the inspector reference section. If you want to leave the scene empty and have the map generate at runtime, click Clear Map and turn on Generate on Awake. Then press play and a map will be generated in play mode. You can also trigger the map generation via scripting by getting a reference to the MoraMapGen component and calling its Generate Map function. Now that you're ready to fully customize your levels with your own prefabs, let's build the setup from scratch. In your scene, add a new game object centered in the world, add the MoraMapGen component. Now create your settings asset by either clicking the New button or by right-clicking in your Assets folder and selecting Create MoraMapGen MapGen Settings Asset, and then assigning it in the inspector. Before we tweak any settings, let's create a new area options asset, either by clicking New or by right-clicking in your Assets folder and selecting Create MoraMapGen Area Options, and assigning it in our settings. The area options is a list of rooms and corridors that the map layout should use. These are called area definitions. The tile module edge size is very important. You'll need to set it to the size of your module meshes. We'll get to that later, but keep this in mind. There are several categories for area definitions. Required unique rooms are for rooms that the map needs to contain exactly one of them. Optional unique rooms are rooms that are not critical to be included, but if they are included, only one should be used. Optional common rooms are also rooms that are not critical, but they may also be used multiple times in the same map. There are also required unique corridors, optional unique corridors, and optional common corridors, which are the same as the room categories, but for corridors. At the bare minimum, you'll need to assign the default room and default corridor. Both of these can use the same area definition. For now, let's create two new area definition assets. Right-click in your assets and select Create MoraMapGen Area Definitions. One called Default Room and one called Default Corridor. Assign these to the defaults in your area options asset. Now let's look at one of these in the inspector. Here is where you can assign props specific to this area, but I'll cover props in detail later. Right now we need to assign a tile module definitions asset to each of our area definitions. A tile module definitions asset defines the module prefabs to use. That is, the skin used by any areas that are using it. Multiple area definitions can use the same tile module definitions, so let's just create one for both of our defaults to use. Right-click in Assets and select Create MoraMapGen Tile Module Definitions. We'll call it Default Modules. Let's assign it to both of our area definitions. And back in our default modules inspector, let's look at what we need to assign. These are the various module categories that are used to build each tile of our map. Toward the bottom are the same prop categories we saw earlier in our area definitions. Props assigned here will be used in any room or corridor that uses this tile module definitions asset, as well as props specific to that room or corridor. Again, I'll cover props later. For now, we're focusing on modules. To understand how these are used, I'm going to demonstrate in the basic demo scene. First, in the MapGen inspector, I'm going to scroll down to the debug options and enable Spawn Sprite Templates. What this does is spawns the sprite that was used as a template for each tile in our map. If you want to see what this looks like, you can enable Don't Spawn Game Objects, and then when you generate your map, you'll only see the layout as a grid of these sprites. We're going to keep that option disabled and regenerate the map. I'm going to select any one of these map tiles and isolate it to show you the module prefabs in place. Because I had Spawn Sprite Templates enabled, it contains this game object. You can see how it's made up of straight wall prefabs, an outside corner and an inside corner prefab, and some floor prefabs. We need to create our own for our setup. I won't go into detail about how 3D modeling works, but we'll assume either you will be modeling your own meshes or we'll be using some from an asset you acquired elsewhere. For this example, I'm going to use these meshes I created in Blender. I have a straight wall, inside corner wall, outside corner wall, floor, interior ceiling, and exterior ceiling. You can have as many options for each of these as you want. Now, it's important to use a consistent size for your models, at least on the ground plane. They should be square, but the height doesn't matter as far as this system is concerned. It is super important that we make note of the size of the square dimensions. In this case, I've modeled my module meshes to be 3 units in both dimensions. So before we forget, let's select our area options asset and type that number into the tile module edge size field that we made note of earlier. With our meshes ready to use, I'm going to start creating the prefabs to assign in the tile module definitions asset that we called default modules. I'll show you the workflow for this example on one of the prefabs and then speed through the rest since it's the same process. We'll start with the wall straight. Let's right click on our project and select Create Prefab and call it Wall Straight. Inside, let's just add a cube, rename it to Mesh, and then change the mesh in the Mesh Filter component to our Wall Straight Mesh. Don't forget to assign materials as needed, and if you're using Blender, you may need to rotate your mesh. That's it. Now we can assign this wall straight prefab to the walls straight list. Again, you can create as many different alternate prefabs as you like. Give them different weights if you want some to be more or less common than others. Now I'll just create and assign the rest of the prefabs. Now for the doors, there are 2 approaches, and you only need to do one: whole doors or half frames and panels. In your settings asset under door placement settings, you can specify which door placement mode you'll be using. Let's use the half frames mode. The way doors are placed is they are instantiated at the center of the floor where a room and corridor tile meet. For whole doors, it's just one prefab for the entire door, but with half frames, it instantiates 2 halves of the frame and 1 door panel prefab, all at the same spot. Since we're using the half frames mode, we need 2 prefabs, a half frame and a panel. Assign these to your tile module definitions. Now everything is in place to start generating maps. Select your MapGen object and click Generate Map. It looks very bland since we're using the same set of prefabs for the entire level, but now you have everything you need to start creating more area definitions and more tile module definitions with a wide variety of module prefabs to skin your rooms and corridors. To spawn props in your maps, first we need to add the prop placement component to the same game object as our MoraMapGen component. The prop density master controls the overall density of props in the entire map. Overlap tolerance is how much props can overlap each other when placed. If a prop being placed would overlap an existing collider by at least this amount, its placement will be canceled and it will attempt to place a different prop at that spot. Procedural offset defaults is where you assign an asset that defines how much variance in position a prop can be placed on a procedural prop spot. More on those later. Next, we need to add prop spots to our module prefabs to determine where props should be placed. In one of your module prefabs, add a new empty child game object and position it where you want a prop to be attached. Make sure your tool handles are set to pivot and local. This way you can visualize how the pivot of a prop will be rotated. Treat the pivot of this game object as the pivot of a potential prop. Wherever the Z forward handle is pointed is where the prop forward will be facing. Now add a prop spot component to the empty game object. Prop spots use a prop channel to determine which props can be placed here. Later when we define our props, they will also be assigned a prop channel, so props will only be placed on prop spots with the same channel. Let's create a new prop channel by right-clicking on our project and selecting Create, MoraMapGen, Props, Prop Channel, and name it Wall. Then assign it to the prop spot. You'll notice the name of the game object automatically updates to show what channel it is for. The next thing you can do with your prop spots is adjust the placement variance offsets. These allow a prop to be placed with some positional offset from the center of the prop spot. Each component offset can have a negative minimum and a positive maximum. When you adjust one of these values away from 0, you'll start to see a histogram visualization of the frequency of props being placed anywhere within that range. It looks noisy at first because it defaults to a uniform distribution. Change the mode to normal and you'll see the histogram look more like a bell curve. This means props are more likely to be placed near the actual pivot. The lower the spread factor, the tighter the curve gets. When at 0, it's the same as no offset at all. When it approaches 1, it becomes basically the same as uniform distribution. The biased mode makes one extreme of the range most likely, with the other extreme very unlikely. The higher the bias strength, the closer to the extreme the samples get. If set to 0, it's basically uniform. You can also flip the bias. Let's also add a new prop spot to this pipe and distribute it across the length. We also need a new prop channel called Pipe. Now that we've placed prop spots in our modules, we need to assign props in your area definitions and tile module definitions. Props assigned in tile module definitions will be spawned in any room or corridor that uses those tile module definitions, and props assigned in area definitions will only be used in those specific rooms or corridors. There are several categories of props. Required unique props will be spawned exactly once. Use this category for a unique prop that needs to be sure to spawn and not have any duplicates in the same room. This category is ideal for gameplay and story-critical props such as objectives. Required common props will be spawned at least once and could be spawned multiple times. Optional unique props are not guaranteed to spawn at all, and at most only one of them will spawn. Optional common props are also not guaranteed to spawn, but there's also no limit to how many could spawn. This category is ideal for set dressing. Always spawn props is a very different category from the others, so we'll cover this one last. Let's say we want to place valves on some of these pipes. We'll start by adding a new required common prop. I'll assign my valve prefab to the prefab field, then click the placement dropdown and select on prop spot. The other options you see are procedural prop spots. These are features of your generated map and are not placed manually like prop spots. With on prop spot checked, you'll see a prop channel field. Assign the pipe prop channel we created earlier. Before we go further, let's test our prop by going to our MoraMapGen component and clicking Generate Map. We should now see valves on a lot of the pipes. If you don't like how many there are, you can adjust the density either by adjusting the master density in the prop placement component, or the overall density of the area definition, or even by adding a prop channel density multiplier. You can also optionally assign a prop rotation settings asset to allow these props to be rotated in some way. If we want our valves to be rotated on the Z-axis, we need to create a new prop rotation settings by right-clicking on our project and selecting Create, MoraMapGen, Props, Prop Rotation Settings. I'm going to call it Free Z. This is very similar to the placement variance offsets you saw in the prop spot, but for rotation. You get the same distribution modes, but you also can set a rotation increment, which snaps rotation to a multiple of whatever degrees you specify. Maybe you want a prop to be able to rotate up to 90 degrees, but only in 45-degree increments. The plus or minus values allow a further deviation from those snapped values. Great for when you want a prop to always be rotated by 90-degree increments but not look artificial, like a bed or dresser against a wall won't always be perfectly square. For our free Z rotation, let's allow it to rotate between -180 and +180. Let's leave it at uniform distribution and then assign it to our prop definition. Now when we regenerate our map, the valves will all be rotated differently on the Z-axis. Let's talk about procedural prop spots. They exist implicitly wherever a tile matches the criteria. They are a world position vector 3 at the center of the tile on the ground. And they are corridor door spaces, corridor straights, corridor corners, corridor intersections, which could be 3-way T's or 4-way X's, room door spaces, room corners, room centers, which are actually at the center of the maximal unbroken rect within the room, and dead ends. Let's place a crate on the ground at these spots. I've created a simple prop with its pivot centered on the ground. I'll assign it to a new required common prop in our modules asset so it applies globally. When a prop definition includes any of these procedural prop spots in its placement options, it may be placed at the corresponding spots in your map. I'll set it to room corners for now. Let's regenerate the map to see them get placed. Now there are crates in the corners. Let's make them also spawn at room centers and corridor intersections. Here's one in the middle of a room and one at an intersection. You can also override the procedural offsets to use. To create a procedural prop spot offsets asset, right-click in your project and select Create, MoraMapGen, Props, Procedural Prop Spot Offsets. I'm going to call it Subtle XZ to give props a little deviation to their placement on the ground. You could set different offsets per spot, or you can enable Same for All to keep it simple. I'm going to give a small offset to X and Z with normal distribution. Let's assign the new offsets to the prop definition and regenerate the map. The crates now have a subtle offset on the ground. Let's also create and assign a new prop rotation settings asset called Approx Incremental 90, because we want them to be rotated in 90-degree increments and be given a subtle deviation instead of being perfectly snapped to 90. Let's regenerate again to see that happen. You may have noticed the weight field and that it isn't used in required unique props, but is used in the other categories. When props are being placed, the code loops over all prop spots and tries to place a valid prop. If multiple props are defined that share the same placement and channel, that's where the weight comes in. A prop with a higher weight will be more likely to be selected. When a prop is selected and successfully placed, the spot won't get used again for any other props in these main categories. That brings us to these always spawn props. Unlike the other categories, density doesn't apply, and whether a spot has already been used or not doesn't matter. Collider overlap does still matter. When prop placement gets to this category, it then attempts to place one of these props on every prop spot or procedural prop spot that matches it. You'll also notice that each entry in the list contains its own list of prefab options and weights. Let's say you have several light prefabs and you want to randomly select one light from all possible lights and place one at each room corner, for instance. You can do so. What if you want crates to be placed against the wall? We can start by adding prop spots in our wall modules and assign them a new prop channel called wall floor. Right now they will fail to be placed if your modules have colliders because placement at these pivots will result in them intersecting the walls. And even without colliders, they won't look right. This is where prop anchor overrides come in. In the prop prefab, let's add a new empty child and attach a prop anchor override component. Set its placement to on prop spot and assign it the wall floor prop channel. Now move the child object to the position and rotation where you want the wall to be relative to the prop. I'll put it right here so that it's placed with this side against the wall and so that there's a small gap between it and the wall. By default, any rotation will be applied around the root pivot of the prefab. But if for any reason you want it to rotate about a different pivot point when being placed using this anchor, you can create and assign the transform here. You can also have as many anchor overrides as you want in a prop prefab and even have various prop channels represented as well. When it comes time to get placed, if there are multiple anchors that match the prop channel of the spot, it will just randomly select one of them. Before we forget, let's set one of these prop definitions to also spawn on prop spots using the wall floor channel and then regenerate. Another situation you might encounter is when you need props to have some breathing room around them and not get crowded by other props. This is where the prop placement volume comes in. A good example is a bed. If you want it placed with the headboard against a wall and no other props blocking its sides, in the prefab we'll add the appropriate anchor override. And then to ensure that entrance to the bed never gets blocked, we'll create a new empty child game object and add the prop placement volume component. It requires a collider to define the volume we want to prevent props from encroaching. We'll add a box collider and set it to cover the volume that we want. These child objects get deleted on start, so don't attach any other components or children to them. Now we'll just add the bed to the default room area as a new required unique prop, and set its placement to on prop spot and assign the wall floor channel. When we regenerate the map, we'll see one bed and no wall crates within the space around it. That covers everything you need to know to start filling your maps with props. If you need to implement your own code that runs before, during, or after the prop placement phase, implement the MapGen post-process interface located in Scripts, Runtime, Advanced. If you need any code to run on a per prop basis immediately after the prop is placed, Add your own components to the prop prefabs, implementing the iProp Post Placement interface, also located in the Advanced folder. That's a mouthful. Depending on your art style, you may want to use reflection probes in your scene. While you could just treat them as props and use the prop placement system, it wouldn't be very efficient, as you'd either have not enough probes to cover the entire map or you'd have way too many, killing performance. I've included a component called Reflection Probe Placement. It implements the MoraMapGen post-process interface, so you can control whether you want it to process probes before or after props are placed. You can provide your own reflection probe prefab if you want, and specify how high off the ground the probes should be placed. Then, most importantly, you can specify which prop spots to place them on. This is similar to how prop placement works, but the key difference here is that the reflection probe placement component procedurally determines the bounds of the probes to ensure they cover the entire room or the entire stretch of the corridor that they're in. Try starting with just on-corridor door spaces, corridor corners, and room centers to see if that suits your needs. Find the optimal placement that works for you. When you've generated a map, you can select the reflection probe's child object, and as long as your gizmos are visible, you'll see a visualization of where they cover. If the overlap makes it hard to see exactly which is which, just select one and you'll see its coverage. Those placed in rooms will expand to completely cover the room, and those placed in corridors will expand in each direction until they hit a wall. The MoraMapGen system is compatible with the NavMesh system in Unity's AI navigation package. As long as a NavMeshSurface component is attached to the same game object as the MoraMapGen component, the NavMesh will get baked when the map is generated. Normally you'd bake this in the editor, but since runtime generation is where this really shines, it does the baking for you at runtime. Just make sure your module prefabs have appropriate colliders if you're using colliders for the NavMesh baking. In this section, we'll walk through everything in the MoraMapGen inspector. When no settings asset is assigned, the inspector looks very small. It's divided into 4 sections: generation options, settings, debug options, and advanced settings. With a settings asset ready and in place, the inspector gives us a lot more options. The Generate Map button will generate a new layout, whether in edit mode or play mode. The Clear Map button removes any existing map. The Bake to Prefab button saves the current map as a prefab. When the Generate on Awake toggle is enabled, a map will be generated in play mode during Awake. If off, you need to either have it generated and saved in the scene in edit mode, or at runtime get a reference to the MoraMapGen component and call Generate Map manually. Note that if Generate on Awake is enabled and you generated a map in edit mode, when Awake is called, it'll just clear the map and regenerate a new one. Next is the randomness settings. Random seed is the seed used for map generation. As long as your settings stay the same seed will always produce the same map. When randomized seed is enabled, the random seed will be ignored and a random value will be used every time. If you ever generate a random map and want to know what its seed was, it will be printed in the console. Next is the map size settings section. If you want a map of a specific size, turn off Use Random Dimensions and then specify the exact dimensions that you want to use. If Use Random Dimensions is enabled, then the size of your map will be random, with each side being a length between the min and max. Clamp area keeps the total size of the map within a min-max. This is useful to prevent tiny or enormous maps when your min dimensions is really small or the max dimensions is really large. For instance, you might have the max set at 50, but maybe you don't ever want a map that's 50 by 50. This prevents that. The next section is ceiling options. The exterior ceiling is visible from outside and fills the empty space. Here's what the map looks like with it disabled. The interior ceiling is visible from below. Here's with it disabled and enabled. Up next is area settings. The area options is the required asset that determines which rooms and corridors to use when building your map. Min rooms ensures that the layout generated has at least this many rooms. The minimum is also based on the number of required rooms in your area options asset. The layout will always include enough rooms to satisfy both criteria. The room creation modes are different strategies for generating room shapes. Random generates them by wave function collapse, so they are truly random. The chunks mode divides the map into a grid and then places a predefined room shape in each cell. We'll cover room shapes in more detail shortly. The hybrid mode combines both random and chunks, with some cells using room shapes and the rest being filled with wave function collapse. You can control the blend between chunks and random rooms with the hybrid chunks factor slider. Depending on what mode you select, a different set of options will appear below. For the random mode, the first option is nearest room tie threshold. When pathfinding happens, to connect the rooms with corridors, each room looks for the nearest room to connect to. If this is set to 3, then a room that is 3 tiles away will be treated as tied with a room that is 1 tile away, and then the connection could be made to either. If remove small rooms is enabled, then any generated rooms that are too small will be deleted. A room is considered small if the number of tiles making up the room are equal to or less than the small room size setting. If split large rooms is enabled, then any generated rooms that are made up of a number of tiles equal to or greater than the large room size will be split into multiple rooms as many times as it takes to ensure that all resulting rooms are smaller than the large room size. When using the chunks room creation mode, you get these settings. The room shapes path is the location relative to a resources folder that contains the room shape assets you want to use. I've included lots of room shapes in the demo folder inside Demo, Resources, Room Shapes. Note that if you don't want to use these in your maps, either delete them or specify a different room shapes path to point to only your room shapes. The room connection modes determine how rooms are connected to each other. Neighbors means that a room will try to connect to an orthogonally adjacent neighbor in the grid. Proximity uses the same method as the random mode, with connections being made based on how close the rooms are to each other. This exposes the same nearest room tie threshold setting. Chunk size min-max determines the min and max dimensions of the cells when the map is divided into chunks. Note that if your room shapes are too large to fit within the min-max setting, then they won't be used unless two cells get merged, resulting in a cell that is large enough. Min chunk quantity ensures that the resulting map will have at least this many chunks, but again, if your area options require more rooms, then the layout will accommodate them. The merge chunks min-max setting determines how many times some adjacent cells should be merged into larger cells. When hybrid mode is selected, you get all of the relevant settings from both modes as well as the factor slider. After rooms are set, then the corridor design settings come into play. With none of these toggles enabled, the corridor layouts could be messy and clustered. Might not be exactly what you're going for your layouts. When corridors are placed to connect rooms, by default they will connect to any part of the rooms, but if direct routes is selected, then they will take the shortest path possible, connecting the two nearest tiles from both rooms. Corridors fill space simply adds more corridors to the empty spaces. You can control how much of the empty space gets filled with the % slider. 0 is the same thing as being disabled, and 1 will try to fill the entire map. Even when it's set to 1, in rare occasions a space will still be empty if there's no legal tile placement that can go there, depending on your sprite templates. When pathfinding is connecting rooms, by default it ignores any previously placed corridors, but with consolidate paths enabled, if a path runs into a corridor that already connects to the destination room, then pathfinding will end. This tends to prevent a lot of clustered loops. Lastly, the dead ends reduction factor determines how many dead ends to attempt to eliminate by either removing them or connecting them to other paths. If set to 0, then nothing will happen, but if set to 1, then your level will have no dead end corridors. Under door placement settings is a door placement mode, which can be set to either whole doors or half frames. This determines which door module prefabs to use from your tile module definitions. Whole doors simply places a complete door at every room entrance, whereas half frames places only half of the door per area. This way each side of the door frame can match the look of the room or corridor it faces. There is also a Unity event called onBakedMapReady, which passes the baked map object when the map is done being generated and ready to use. You can also add listeners to this event via scripting by getting a reference to this MoraMapGen component. Now we have the debug options. Show logs will print more logs about the map generation process. Show WFC animated, that stands for wave function collapse, will show the map being generated step by step in play mode rather than being done instantly. This is really just for visualization purposes. Spawn sprite templates will add a sprite object to your tile objects. I often couple this with enabling don't spawn game objects, which prevents modules from being spawned, so you can see a sprite-based visualization of your layouts. Validate maps loop only works in play mode. What it does is continually generate maps over and over. With spawn sprite templates and don't spawn game objects enabled, as well as randomized seed also enabled, this is useful for validating that your settings and props don't result in a bad layout or critical props failing to spawn. The notes field is just a simple text field. It doesn't do anything. I've used it to make note of specific seeds that I want to remember for testing, and that's about it. The last section is advanced settings. You likely won't ever need to touch these, but they're here. The sprite templates path is a path relative to the resources folder where your sprite sheet is located for defining tiles for the map generation. The default one is in MoraMapGen, Resources, Sprite Templates. Any and all sprites located at this path will be used. They don't even have to all be in the same sprite sheet, but also make sure not to put any other unrelated sprites in this folder. These next three weight settings have only to do with the initial wave function collapse that happens during the random room creation mode. Whenever a tile is collapsed, that is to say randomly selected, if there are multiple valid tiles to select from, the weights will be used. So with these settings, a corridor is 3 times as likely to be selected as a room, and dead ends are not very likely. The following 3 pixel color settings are set to specify which pixels in the sprite templates are used for corridors, rooms, and walls. You really shouldn't ever need to touch these. That covers everything in the MoraMapGen inspector.